Howdy! Today on Flipping Science we're going to be looking at delta H calculations. So what is delta H? Delta H is the symbol for enthalpy. Enthalpy is a description of how much energy is released or absorbed when a chemical reaction occurs. So it's the change in heat energy that occurs in a chemical reaction. So in some reactions you have a lot of energy stored in the reactants and less energy stored in the products. So when a reaction occurs you get a release of energy to the environment, and that's this change in energy here. In some reactions you have less energy in the bonds of your reactants and more energy in your products. And then energy goes into those substances, and the difference in energy between the reactants and products is the delta H value, the enthalpy change of that reaction. If a reaction gives out energy to the environment, it's exothermic, and if a reaction takes in energy from the environment, it is endothermic. So the formula we're going to use and rearrange is this one. So delta H is equal to the specific heat of water, which is 4.2 joules per gram per degree Celsius. Depending on what you might be told to use, you might be using 4.18. The change in temperature of the water that you're heating or cooling down in the reaction, the mass of water that you're heating or cooling down, then you divide that by 1,000 times the number of moles of reactant. So let's do an example question. So what I'm going to do is I'm going to highlight the important information as we go through so I know what I'm looking for. So we're burning some methanol. It's heating 150 mils of water. We've got the mass of methanol burnt. So if we know the mass, we can figure out the molar mass, we can figure out the number of moles of methanol burnt. We can figure out the temperature change there. So 25 to 18 is 7 degrees Celsius. And we've got our specific heat of water here, 4.2 joules. So now we can calculate the heat energy. Now to calculate the heat energy, this is just the energy that's going out in the reaction. It's not the amount of heat energy in kilojoules per mole. So it's not a delta H value, it's a delta E. It's a change in energy value. So now I'm going to put all that information into the equation. So we've got delta E equals specific heat of water times by the change in temperature times by the mass. So in this case it's 4.2, which is our value from over here. Our change in temperature is 7 degrees from here. And our mass of water, 150 mils of water weighs 150 grams, so it's 150. I'm going to get my calculator up, and so 4.2 times 750. Right, so 4,410. So 4,410 joules. So that's in joules. Right. The next part of the question is asking me to calculate the molar enthalpy of combustion. So that's my delta H value. So I'm going to fill in the entire equation, and then I'll go back to my calculator. So delta H equals Cp times delta T times M over 1,000 times N. Put in my numbers. So 4.2 times by 7 times by 150 divided by 1,000 times by, now to figure out my number of moles I need my mass over my molar mass. So if I go back I can see my mass was 0.34 grams. 0.34 grams. I'm going to divide that by the molar mass of the methanol, so 12.01 plus 4 times 1.008 plus 16 for the oxygen. Right, I'm going to get my calculator up. So I've already got that first bit there, so now I'm just going to divide by,
open up the brackets, 1,000 times, other brackets, 3, 4, divided by 12.
so I get 415.6. So because it's an exothermic reaction, we need to put a negative value out the front first. So negative, so 415.6. Then our unit is kilojoules per mole for mole enthalpy, so for delta H. So let's do this question now. So we've got a second question. So again, I'm going to highlight the important bits. So we've got butane there. We're given the delta H value. We're given the mass of butane that's burnt. We're given the amount of water that we're heating up. And we're given the initial temperature. So in this case, what we're trying to find is the maximum temperature that can be reached by the water rather than the delta H value. So we need to rearrange our delta H equation. So delta H equals Cp times delta T times by mass of water divided by 1,000 times N. So now we need to make delta T the subject of the formula, so I'll put that over this side, so delta T. Now if this is divided over this side, we need to multiply it over this side, so delta H times 1,000 times N, and these two here are being multiplied, so we need to divide that out, so Cp times by mass. So now we can substitute in our values, so we've got delta T equals 2,874 for the delta H value, times by 1,000 times by our number of moles. So in this case, we're burning 1 gram. Our formula, so 4 times 12.01 plus 10 times 1.008. Close that off. And that's divided by our specific heat, so 4.2 times by the mass, which is 1,000. So 1,000 mils is 1,000 grams. Now since there's 1,000 on top and 1,000 on bottom, we can cancel those two out. So now I bring up my calculator. And I get 11.77. So round that off, I've got 3 significant figures out here, so 11.8 becomes degrees Celsius. My final temperature, TF, I'm going to call that, is going to be my initial temperature plus my change in temperature. Now because this is warming up the water, we're adding that. So go back to my calculator, plus 18.5, and I get 30.3 when that's rounded off. So my final temperature is 30.3 degrees Celsius. So there's some examples of the kinds of questions you'll get when we're looking at enthalpy of combustion questions. That's it for Flipping Science today. See ya.